Hello, everyone, and welcome back to all our frequent visitors to the RVIA Standards mini webinars. I am Mick Sass. I'm one of the 6 RVIA inspectors, and today we will be discussing connectors and terminals in the 12-volt system. Connectors and terminals are used to slice and join wiring to the 12-volt components and devices in our RVs. Here are some examples of connectors and terminals used to splice and join wiring in the 12-volt system. The proper use and installation of connectors and terminals will reduce the possibility of accidental shorting. Note that connectors and terminals in this low-voltage system do not need to be listed. These requirements are detailed in the ANSI RVIA Low-Volt Standard, yellow document on the left. The information is more fully explained in the Guide to the NFPA 1192, also referred to as the RVIA Handbook. The handbook is a large 3-ring binder that covers everything, including the low-volt standard, 120-volt electric, propane systems, safety concerns, and plumbing. Connectors and terminals used in the 12-volt system are marked for use with specific wire sizes. Here we will see some examples of these markings. First example is of Scotch line. As you can see here, the package cover illustration details the size wire these connections will accommodate, 18 to 14 gauge wire. Another example would be this container of yellow and red wire nuts. On the side panel of this plastic container is a breakdown of the size and number of wires that can be connected under the red or the yellow wire nuts. There's a wide variety of connectors and terminals available on the market today. All are marked with the intended wire size and associated number of conductors that are suitable for each size connector or terminal. Here is another example where the packaging of connectors has its technical data marked on the front panel of the packaging. As you all know, listed low voltage wiring is marked with its gauge size on the wire insulation. Always ensure that the connector or terminal being used matches the size marked on the wire's insulation. If the wire size and number of conductors are not marked on the packaging itself, a technical data sheet is usually provided within the packaging. Here, a butt connector is too large for the 18 gauge wire being connected. However, there is a fix for this situation. If this is the only size connector available at the time, you can double back on the bare wire to provide the adequate circular mill area, which is basically the diameter or thickness of the wire, for the connector being used. Again, refer to the technical data information on or within the packaging to determine if doubling the thickness of the wire will be adequate. Then, install the trim or connector as normal. There are acceptable connectors and terminals designed for all types of devices and connections. Here, a flat spade will require a terminal that matches both the configuration and the wire size. The proper use of crimping tools is also vital in attaching terminals and connectors. Here, we see a crimping tool that can be used for both insulated and non-insulated connectors and terminals. In the RV industry, the vast majority of connectors and terminals in the 12-volt system utilize the insulated variety, as seen here with these butt connectors on the right. For these insulated connectors and terminals, the insulated bite of the crimping tool will be used. Because of its curved, smooth shape, the plastic insulation of the connector is not damaged when being crimped onto the wire. This provides a secure connection between the two wires with no exposed conductor through the plastic insulation. When the non-insulated portion or bite of the crimping tool is used, which has a sharper configuration, damage to the insulation is possible, as seen here on the right, where the non-insulated bite of the crimping tool cut through the insulation, exposing their conductor and the possibility of shorting. On non-insulated terminals and connectors, the installation must assure that the insulation grip of the non-insulated connector is being secured through the wire's insulation, as seen here. These types of terminals contain a grip for both the copper conductor as well as for the wire insulation. Two properly attached terminals are seen on the right, illustrating both that the copper wire and the green insulation have been crimped on securely. In some terminal configurations, plastic sleeves are provided to cover all the conductor terminals, including the portion that mates to the 12-volt device or component. When using non-insulated connectors and terminals, the connector or the terminal must be flush with the conductor's insulation. Any exposed conductor shall be covered with a minimum of 3 wraps of electrical tape. This is also true when applied to insulated conductors or terminals. Any exposed conductor must be covered with 3 full wraps of electrical tape. Although there appears to be no exposed conductor on this sharply cut wire insulation, it is considered to have an exposed conductor. Again, any exposed wire, such as a hot end on a scotch lock, must be properly covered with 3 wraps of electrical tape. With bell caps and other connectors or terminals, assure that the wire's insulation is completely within the protection of the connector or the terminal to avoid shorting. The wires on the left are fully protected by the bell cap, leaving no bare conductors exposed. The photo on the right shows conductors that are exposed and not completely covered by the bell cap. As with any potential configuration that could cause a 12-volt short, if there is a gap between the end of the connector or terminal and the wire's insulation, a minimum of 3 wraps of electrical tape is required. When splicing conductors, simply twisting the conductors together and taping them is not an acceptable means of joining conductors. In this case, a wire nut mechanically secures the conductor strands together. Additional taping of the wire nut to the wire's insulation is acceptable, but not necessarily required. Multiple wires in a single connector or terminal is acceptable if the circular mill area, diameter of all the conductors being joined, is within the specified range of the terminal or the connector being used. To determine how many conductors are acceptable under one terminal, always refer to the technical data information provided with the conductor's packaging. For example, here one yellow nut could hold between 1 and 3 number 12 wires. To determine how many conductors are acceptable under one terminal, always refer to the technical data information provided or on the packaging. For example, here, one yellow wire nut could hold between 1 and 3 number 12 wires, or one number 10 with one number 12. 14 wire with anywhere from 3 to 5 number 18 wires. And as you can see on the chart, there are many combinations of wires for both yellow and red wire nuts to accommodate. An additional source for the number of wires that can be joined with a specific connector or terminal is provided in the guide to the 1192 handbook. This chart here is seen in Chapter 6 on Chart 6-1.3. Again, this is a general guide. Between this resource, the technical data information provided with the connector packaging should be able to determine the correct use of wires in specific terminals or connectors. Finally, be sure that the terminals being used are sized properly for the post or stud provided. The conductors on the right side are fitted with the proper size ring terminals. The center auto circuit breaker post is fitted with an oversized ring terminal. This could cause poor connection or the loosening of terminals from the post. And the two large ring terminals on the left are fitted with an additional washer to compensate for the oversized ring terminal. This is also not acceptable as the post may not remain centered. So in summary, basic takeaway from this mini webinar is that the connectors and terminals being installed on any conductor or wire must be properly sized based on the size of that conductor. And multiple wires can be joined together as long as the circular mill area, the diameter or the thickness of the conductors being joined, fall within the specified limits of the connector or the terminal being used. And all conductors must be covered. This means no gap between the wire's insulation and the end of the connector or the terminal. If the conductor is exposed, 3 full wraps of electrical tape will need to be installed to adequately protect the conductors from shorting. Finally, twisting and taping conductors is not an acceptable means of joining wires. And thanks for viewing this RDNA